So when we talk about the sum of a series, okay, we want to kind of use the visual and use the kind of thinking that we're looking at the area under this curve. Okay, so when we talk about the sequence, for example, an infinite geometric sequence of 1/2, 1/4, 1/8, etc. Right? So this is our series. Okay, this is our sequence here. And when we put it in a sigma notation, this means the sum of this sequence, so that this is a series. And essentially we're looking at the area under this curve. Okay, because if we take a look at how we find the sum of this series, well, each term we're going to give it a width of 1 and a height of that sequence number. So in this case it's going to be 1/2 times 1. So the height is 1/2. We're going to give it a width of 1, so that's going to give us an area of 1/2. This is going to be the height of 1/4, okay, and then the width of 1. So this is an area of 1/4. So this is going to be 1/2 plus 1/4 plus 1/8, etc. And although we're looking at the area of these rectangular blocks, when we think of, you can either think of these individual, discrete rectangular pieces, or you can even think of the area under the curve, because although they're not the same, they essentially are behaving like one another. Okay, so when we talk about the sum of a series, okay, we're talking about essentially the area underneath those curves, or the areas underneath those dots. So that's how we're going to kind of have a visual sense of what we're doing. So when we actually graph the sum, okay, so if we graph the sum on the y-axis, in order for it to be converging, this sum has to eventually go to a limit. Okay, this is a converging series if it does that. A diverging series, so one that the sum is infinite, is just going to go up like this. It may keep bending down, it might get smaller and smaller, but it's eventually gonna keep on going up, eventually go up to infinity. Okay, so that is a diverging series. So when we talk about a series, we have converging, diverging. Okay, converging means it goes to a limit. Okay, converging means it has a finite sum. Diverging series has an infinite sum, and it has no limit as n goes to infinity. Okay, so that's important to start understanding that terminology, converging, diverging. So again, it is important, if we don't add zeros at the end here, okay, we're going to just keep on getting bigger, and there will never be a limit. So this is a necessary condition for us to have a finite sum. However, it's not sufficient, because we have already seen examples, in particular the harmonic series. This one here, although it has the an, each term eventually goes to 0, the infinite sum of this is infinite. Okay? It is a diverging series. So we cannot use that as a criteria to say just because an goes to 0, it converges. We can say that series only converge if an goes to 0, but they do not always converge. Okay, so we'll start taking a look at these more and more. But again, I want you guys to take a look at those videos, just get a sense of what we're doing, just get a sense of understanding what a series is, and we're going to start looking at more and more series to get a sense of which ones converge, which ones diverge. And it's important to just kind of get a sense of that.